In this video, we will continue to introduce the applications under the Transmit main menu. TouchTune. Regarding TouchTune, we know that the TouchTune's player uses a wireless remote control. This remote control transmits NEC encoded information via 433.92 MHz frequency in ASK or OOK encoding mode. The wireless information is identified by the PIN code 000255 to prevent interference between mobile devices. The TouchTune application can modulate audio files on the SD card to the radio frequency and transmit them as FM radio signals. To access this application, you select the 3 digits to the right of PIN and change the value of PIN using the knob. The range of PIN is from 0002 to 255, and by default, it is 000. If you enable the scan function, it means that the TouchTune application will start transmitting commands from PIN number 000 at a frequency of 256 times. After all the command transmissions are completed, the PIN will become 255. When the EW mode function is enabled, TouchTune will continuously send continuous wave signals on 433.92 MHz, attempting to interfere with the receiver of the player. During the use of EW mode, you can still send instructions. After completing your settings, you can click any button on this screen to send instructions. Now, we can use the audio application in another HackRF H4M to receive this audio. Set the frequency in audio to 433.92 MHz to ensure that the frequencies of the 2 devices are consistent. Increase the volume of the audio so that we can hear the audio clearly. If we do not select the scan function, then by clicking the button once, the signal will be sent once. If the scan function is enabled, then by clicking the button once, the signal will be continuously transmitted. ADSBTX. The ADSBTX can be used to generate valid ADSB messages. If these messages are transmitted, they may have an impact on the communication between aircraft and navigation systems. Therefore, the experimenters should only use the ADSB signals in a closed radio frequency environment, or ensure that they do not interfere with other normal ADSB communications. To enter this application, you can select and set various parameters including position, call sign, speed, and call sign frequency modulation. In the position information settings, you can input 6 digits or letters through the knob to set your ICAO24 code. You can also choose whether to enable the transmission of altitude, latitude, and longitude. You can set your altitude, longitude, and latitude by using the knobs. Or click Set from Map to enter the map view for assistance with your settings. In call sign, you can choose whether to transmit your call sign and set it with a length of 8 characters. In speed, you can still choose whether to transmit your speed and set the numerical value, ranging from 0 to 999 kN. With units of knots, select your azimuth angle with a range of 0 to 359 degrees. For ease of use, the azimuth angle after input will also be displayed in the circular compass at the top right. You can also choose a vertical rate range of -4096 to +4096 feet per minute. In Quark, You can set the squawk value and choose whether to send it. The range of squawk is 0 to 7777. After setting, click Start to send the signal. We can receive the data through the ADSBTX on another HackRF H4M and see the actual position on the map. Click on Start on the ADSBTX, and then we will be able to receive the information on the ADSBTX. Click on the received signal, and we can see more detailed information. Click on See on Map, and we will be able to see the actual location of the flight on the map. Blam. BLM is a tool designed to demonstrate and test the security of Bluetooth devices. Its core function is to send a large number of false connection requests and notifications to nearby Bluetooth devices, mainly mobile phones, causing an excessive number of pop-up windows, thereby achieving the purpose of harassment or denial of service. It should be noted that conducting a BLRSPAM attack on someone else's device without authorization is likely illegal. Once you enter this application, you can set your frequency, gain, and AMP. Of course, there are various types of Bluetooth data packets for you to choose from, such as Android, iOS, iOS Crash, Windows, etc. You can also choose whether to enable the function of sending random Bluetooth data packets to other devices. Click Start, and the device will start sending a large amount of information. Now you can take out an iPhone to test its functionality. Click Start, and you will be able to see many connection requests on your iPhone, which are the large number of false requests and notifications sent by BLSPAM. Don't worry, BLISPM cannot steal data or connect to the target device, nor will it cause damage to the target device. Restarting the target device will restore it. BLISPAM is purely a harassment or denial of service tool. Burger Pager. The Burger Pager TX can be used to send messages or trigger signals to the restaurant's intercom system. These devices operate at a frequency of 467.750 MHz. In simple terms, it turns your PortaPack into a miniature portable paging transmitter. If a real paging machine has the correct frequency and the address code matches, it will receive the message you sent and ring. To enter the Burger Pager TX application interface, you can set the data you want to send. It consists of 16 letters or numbers. You can choose whether to enable the scan function. If enabled, it means the signal will be continuously sent, and the receiving paging machine will keep responding. If not enabled, click Start once, and the signal will be sent once, and the receiving paging machine will respond once as well. After completing all the settings, you can use the HackRF application in the HackRF H4M to receive the signal. We must ensure that the frequencies of the two devices are the same. When we click Start in Burger Pager, the signal is sent. At the same time, we can hear the paging calls through the POCSAGRX. If you don't enable scan, send once, and the paging call will respond once, like this. If you enable scan, and the paging calls will keep responding, like this. SSTV. The SSTV application uses the method of transmitting static images via radio. It enables you to convert the pixel data of the .bmp image loaded onto the SD card into corresponding audio frequencies, and then transmits them through the HackRF at the set radio frequency. Currently, FM is the only supported modulation method. Once you enter this application, you can select the bitmap image, mode, and frequency to be transmitted through the knob. The modes include Martin 1, Martin 2, SC2, 180, Scotty 1, SOCD 2, and SOCD D. It is worth noting that in this application, the images only support BMP files with a size of 320 by 256 pixels and a bit depth of 24 bits. Since SSTV converts the image signal into an audio signal for transmission, we can use the audio application to receive the signal. When receiving, we must ensure that the transmission frequency of SSTV is consistent with the reception frequency of audio RX. Now, click Start in SSTV to send the information, and at the same time, we can hear the corresponding audio on audio RX. Now, we can try sending another image and receive it again using audio RX to listen to the corresponding audio. Obviously, the images are different. The transmitted audio signals are different.